All right. At this point, you need a graphing calculator. If you don't have one or it doesn't work, your life is about to get miserable. And that's me being real. Can you do it without it? Yeah. As you've seen, I don't have a graphing calculator. Mine doesn't even work. I gave the batteries to Nikki Grantland, and he still hasn't given me batteries back. I'm just joking about that. So you can do it without a graphing calculator. It's just so much easier to do it with one. So this is my words of advice. Please borrow one from a brother, sister, aunt, uncle, nephew, niece, whoever that might have one. You do need it. So 4.3, linear systems in 3 variables. So your entire life, you've only been learning about things in 2 dimensions. But the world we live in is not 2 dimensions. It's not, flat like a sheet of paper. Kind of think of like Doodlebob. Doodlebob is a 2-dimensional figure. But we live in a 3-dimensional world, aka SpongeBob. You guys know what I'm talking about with Doodlebob? You don't, oh, come on, you gotta watch SpongeBob. I'm like 30, almost 36 here, and I know Doodlebob. All right, so essentially we have 3 dimensions, okay? Kind of think of the X and Y axes as like length and width, 2 dimensions, flat sheets. But we have length, width, and height. So now we're gonna be talking about things in 3 dimensions. And it's honestly very difficult to comprehend, okay? So you have the 2-dimensional plane, but then you have one that's coming out. That's your Z direction. So now you have length, width, and height. And these are the ways your things can intersect. And the reason why I say things is because you no longer have a line. Your line is now going to be like a plane. Okay? So kind of think of it as this. Here in the classroom, we have the ceiling, right? That's a plane. That's going to be like a line now. And you have like the wall. So if you think about like, where does the ceiling, this wall, and that wall intersect? They intersect over there in that corner. Okay? It could also be you have the ceiling, the floor, and then, the floor below us. Those 3 planes are parallel. They'll never intersect. Or you could have like, let's say you have 2 planes, these 2 walls here, and you have the back of my classroom. They don't really intersect. They do, but they intersect in lines. So now we have these different dimensions here, and we have different ways they can intersect. All right, so good luck with that. I don't know the other way to explain it other than kind of think of where like ceilings and walls intersect. That's what we're going to be talking about now. All right, a couple different ways to do it. The first way is back substitution. These are very simple. These are like the kindergarten of 3-dimensional problems. Okay? Now, why do I say they're like the kindergarten ones? Because it's not really like 3 dimensions. It's like, hey, 2-dimension, but I give you the 3rd dimension. So what do I mean by that? Notice I have 3 equations, x, y, and z. I have 3 equations, so I need 3 variables. X, y, and z. This is equation number 1, 2, and 3. Notice 3 is already solved for, right? So when I'm doing these, I'm looking for 3 answers, x, y, and z. Now, what I want you guys to do is not copy it down just yet. I just want you to watch. Now, here's how we do these. I already have z. Z is 3. I'm told that in the problem. So I already write that down. Now, what I do is I need to back substitute this. So I am going to take this and I'm going to substitute it in for z. Now, why am I going to substitute it into that second equation? Well, in that second equation, I just have y and z. So if I substitute it in there, I'm going to get y. Then I have x and y, and my life's very easy. So what I'm going to do is I'm going to write y plus 2z equals 5. And I'm going to take this and I'm just going to replace that z. So I have y plus 2 times 3 equals 5. Y plus 6 equals 5. Subtract 6 and you get y equals -1. Now I need x, but I have z and y. So what I'm going to do is I'm going to take this and I'm simply going to plug it in here. So what am I going to do? I'm going to plug in 1 or -1 for y and 3 for z. So we have x minus 2 times the -1 plus 2 times the 3, and that equals 9. So x, -2 times -1 is +2. 2 times 3 is 6. So I have x plus 2 plus 6 equals 9. X plus 8 equals 9. X equals 1. That's my answer. Do you see how easy that actually was? Okay, copy it down. Now, I'm not trying to scare you, but they are going to get harder. But with your calculator, they're actually, to be honest with you, way easier than you want it to be. As long as you have a graphing calculator. Lance, I wish I could share a gum with you, but it's frowned upon nowadays. Do you know what that means? More gum for me.
I haven't had my phone. I think I lost I haven't had it since the first and
Once you're done copying, why don't you go ahead and try B? You can always ask for your extra copies. If I have them, I give them out. If I don't have them, you just eat. All right, I know the bell's going to ring in 1 minute. So we'll start with this tomorrow. See if you can finish that up.